Welcome back, and we learned about the general transformation model. At this point, we know what A, B, C, and D all do. So now let's put them together. Okay, let's see if we can do multiple of them in one exercise. Okay, but the question is, if there are multiple occurring, what's the order? How do we do that? Okay, and one thing I want to caution against is in this general transformation model, remember that this bx plus c is an input into the function. You cannot distribute, right? You can't do like f of x plus b, f of bx, and then plus f of c plus d. You can't do that. That functions don't work that way, okay? So just be aware we have to keep the bx plus c all tethered together, okay? And we might think, okay, well, order of operations, begin with, PEMDAS, work in parentheses. That's generally a good idea. But the order that I recommend doing, and actually, before I get to that, one more piece of commentary. If you don't have the general transformation model, if you have something that looks like a times f of bx, and then inside here there's like parentheses, and then I don't know, I'm going to put k in here, and then plus d. I recommend distributing, so you get a times f of bx minus k, what would this be, bk, plus d, and this would just be your c. But I recommend distributing that out inside of f of x itself. Okay, that is okay. Now, back to my train of thought of we have all these things going on. We have A, B, C. What do we do? You can see my recommendation is to do the horizontal translations first, so horizontal shifts first, and then worry about scalings. You can do horizontal or vertical. It doesn't matter which one. I typically do horizontal before vertical, okay, just so I'm done with the crazy X's. And then lastly, I finish with the D's, the vertical translations, sorry. Okay, to help you remember this, if you think about the letters in the general transformation model, it's C and then BAD. So you might remember C bad, like you're seeing bad, okay, but hopefully you're not having a see bad experience, like you're not seeing bad when you see these problems. Okay, so here we go. We're gonna do one, and I recommend also don't do them all at once. It's a lot to process even for one of them. So do them one at a time and do it well. Okay, so we're going to begin with a graph of f of x is equal to the absolute value of x and use it to get to each of these. So first of all, I like to just identify what is going on here. Okay, so we have let's see, we have two. This is a vertical scaling. Okay, again, I'm not going to distinguish between stretch and shrink in my own practice by factor 2. Okay, and then the negative here is actually -1, and this would be a horizontal. Again, I'm going to use scaling by factor 1 over -1, which is just -1. Okay. This would be a horizontal reflection. Yes, I get it, but I'm going to use scaling only. Okay, and then 3 is actually a negative. Okay, remember the general transformation model was bx minus c. Okay, so -3 is a horizontal shift left 3 units. Okay, and then the last -1 that I see is a vertical shift down 1. Okay, so these are the transformations that I'm going to do, and so what I like to do too is also just kind of write down the order that I would do them in, okay, as well as the algebraic form that I would use for them. So for instance, if I begin with absolute value of x, okay, the first thing that I would do, okay, I just need to identify this is my A, this is my B, this is my C, and that's my D, and just to be clear. I have A, B, C, I have to be careful, and then D there, okay? So then I would use my C first, right? C bad, okay? So, and then this would be, so that is my horizontal scaling by -1, okay? And when I do that, algebraically what I would get would just be, I replace x with the opposite of x, with whatever my scale factor is. Well, 1 over the scale factor, all right? Next, my next transformation would be the B transformation, okay? And so this is going to be, let me go back, that was wrong. C was right, but my, I don't scale, okay? I shift, right? Shift by, let's see, shift by -3, okay? So then I take x and I would have x plus 3, again, minus a negative, okay? So there we go. And I wanted that in blue, x plus 3, okay? Now I can scale, okay? So I horizontally scale by -1. So again, I would take in my absolute value expression, okay? I replace x with negative x, 1 over -1 times x. There we go. Okay, so C, B, and then A would be up next. Okay, so I would have 2. So I would do a vertical scale by factor 2. Okay, and so then this is going to look like, take everything I have so far, the -x plus 3, multiply by 2. And lastly, change it to purple. My last transformation would be to use D, which is my vertical translation. So I would do a vertical shift down 1, okay? And so to what I had in the previous step, I just subtract 1, add -1, okay? And so mathematically, I'm going to see the following graph occur, okay? So again, I would begin with our base graph. Okay, here's my absolute value function. I'll put it in black. Okay, and when you do this, when you graph multiple graphs on the same thing, it's very helpful to label them. So I'll say that this is absolute value of x. Okay, the next one I'll do in blue. Also, colors are super helpful if you have access to them. Otherwise, do some sort of shading differential. So now it says shift left by 3. So let's just take each of the points, and I need to go 3 units to the left for each of them. So let's see, take this point, move it 1, 2, 3 over there, 1, 2, 3 over here, there, and then there and there. Okay, let me just confirm. Yep. So we get something that looks like this. Okay, so this is the absolute value of x plus 3. Okay, next one. Horizontal scale by -1. Okay, so that takes all my x values, and scale means multiply, right? Multiply them by -1. So I'm at -5 here. Now I'm at +5. Okay, and then +4, +3, +2, +1. Okay. So something like that would be the absolute value of -x plus 3. Okay. And if you need to write little coordinates just for yourself, so this is like -5, comma 2, okay? And then recognize that that would go to +5, 2 under a vertical, or under a horizontal reflection. That's perfectly fine. Okay. Next one. I want to vertically scale by a factor of 2. Okay, so that means take the y value and multiply by 2. 1, 2. Okay, so let's see, move that up. Oh, I'm sorry, scale, right? Multiply by 2. So multiply by 2 to the y value of 2. There we go, we're at 4. We're at 1 here, goes to 2, and then 0 is 0, and then 2, and up at 4. So something like this would be the graph of 2, absolute value of negative x plus 3. Okay, and then the final graph, okay, would be just shifted down 1 from all of this. Okay, so I need to shift down 1. Okay, there we go. So move this down, each y value just down 1. Okay, and so this here would be the graph of 2 times the absolute value of negative x plus 3, all minus 1. Okay, so that is one of our basic types of exercises that we'll see in this section, where we have multiple transformations going on and we have to determine the transformations that are occurring, do them in the right order, and then sketch the graph from the base function. Okay, now I could flip the question around. This would be more of a super challenge question. That's kind of fun. So if you imagine the base graph here of square root of x, okay, so this is just the square root of x function. I'm saying construct an equation that matches the graph that's given in red. Okay, how do you do that? Well, I think there's a lot going on here. I want you to try this on your own and maybe bring your idea to class. Try and see if you can identify what the function is using the transformations. I will say that I was able to do this in 3 transformations. Okay, so see if you can do it in 3 transformations as well. Okay, but we'll talk more about this in class. All right, enjoy working on this exercise and be patient with these transformations. They take a while.